networks, facility, and internet exchange points. And the reason why PeeringDB was created, this is really 15 years ago. People who wanted to interconnect needed information for interconnection. And this is also the reason for today that you as a network should definitely have a record in PeeringDB. So if you decide to interconnect to peer, or even only if you want to have transit, you want to interconnect with someone. So, and if you want to interconnect someone, you have to find someone, or the other way around. Someone has to find you. That means you have to publish somewhere your information. And if you don't, no one will find you. It's the same as not having a PeeringDB record. It's the same as when you go to a speed dating and hide in the corner. Please, every network which is peering, which has an ASN, should have a record in PeeringDB and have it up to date. But there is not only information about networks. So one crucial information is also where is your peering partner, your interconnection partner able to find you. That means we also have to have information about facilities. Facilities are colocation, whatever, meet me rooms. That is where networks interconnect. And last but not least, what we also have is information about internet exchange points. Internet exchange points is a nice way to economically interconnect. With one interconnection, you are able to reach thousands of networks. So this is what we find in PeeringDB. Networks, information about networks, facilities, and internet exchange points. And of course, also what is needed from networks is point of contacts. In case something goes wrong, you want to let the others know where they are able to reach you. And this is really nicely tied together both with the graphical user interface and also with an API. And having said that, meanwhile, that the large network have to deal with thousands of interconnections, they simply require that you have a PeeringDB record when you want to peer with them. They are happy to peer on either over the route server or on bilateral basis, but they definitely require you to have a PeeringDB record. The reason for that is very simple. So what they do is, via the API, they retrieve all the information from PeeringDB, which is necessary to set up the BGP session and also to have contact information. And if they can't find this information, they simply refuse to peer with you. So there's also a good reason, not only when interconnecting with big networks, large networks, CDNs or so, to have a PeeringDB record. Does not work. Where I have to point it at? Okay. Next slide is, what I did do is look at PeeringDB and look what is in PeeringDB from in the SAFNOG region from the PeeringDB point of view. So you see several columns. First is the country code, the two-letter country code. Then the next is the number of facilities I found, the number of internet exchange points I found in this country. Next is the number of facilities. Next one is the number of networks at this I-axis. That might be several I-axis. And this also does not necessarily mean that all the networks come from this country. They may come from any country. The next one is the same for facilities. And then I made the joint. That means all the numbers which I either find at the I-axis or in facilities, and just eliminated the double ones. These are the totals. Then I took another point of view. Then I really looked at PeeringDB, how many networks are in PeeringDB where the ASN has been assigned to this country. This information is a combination of what is in PeeringDB, and I also took information from the RIRs. You can fetch information every day, up-to-date information from the RIRs, and they list the AS number and also the country ASN has been assigned to. And the last column is the number of networks I found in this country which were assigned by any RIR. Typically, for this region, this is SAFNOG, but if you look around, you also will find networks which were assigned by PNIC or by RIPE NCC. So this is alphabetically. What I also did, because yesterday I was talking to Yolandi from Africa, she wanted to know how many networks are in PeeringDB or from each region. And what I found out is really that in PeeringDB, I find roughly 1,750 networks from the African region, and roughly, as far as I remember, 37%, it's the highest rate, are also in PeeringDB, which is a good number. And also, if you go down to the South African entry, you will see that we have 330 networks registered in PeeringDB from a total of 538, which is really a good figure. Nevertheless, what you also see is that we have some countries over here in this SAFNOG regions where we still can't find any internet exchange or any facility. And this is definitely something where we probably have to look at. So going back now to PeeringDB, want to talk a little bit about the graphical user interface. The graphical user interface, what you now see is the organization view. So the organization more or less is a root record. And from this root record, an organization might have networks, of course, facilities, and also internet exchanges. On the left-hand side, from the organization record, you find information about the organization itself. So the address, website, and so on. And then on the right, information about the records which this organization has. On the top, you find the information on the facilities which are owned by this organization. So for an example, I took here TISPA, the Tanzania Internet Service Provider Association. It has runs 2 facilities. Next is the networks which are owned by this organization. TISPA has a total of 12 networks. Mostly of them are either management networks or route server networks for their internet exchanges in their different cities. And on the top of the right-hand side, you find information about exchanges which belong to this organization, though. TISPA has a total of 5 internet exchanges. And if a string is highlighted, you simply can click on it and you go on the next level. So if I, for example, go back on facilities, if you click on any of these facilities, you automatically come to the facility record. The same is for networks and of course also for internet exchange. For example, if I click on one of the internet exchanges, I took here the example for Dar es Salaam. It's the same structure. On the left-hand side, you find information on the Internet exchange. This is to which organization it belongs to, then the long name, the city where it operates, the country, also the area where it operates in, the media types it supports, which is not really interesting nowadays because Ethernet. Then contact information for this Internet exchange, and what's more important is the LAN ranges, both for IPv4 and IPv6. And also you find a list of facilities where this Internet exchange is. On the right-hand side, you find all the networks which are connected to this Internet exchange. And how does this information go into PeeringDB? So one of the paradigms PeeringDB has that everyone is responsible for their own data. So the networks decide whether they want to be listed in PeeringDB. And they also decide whether they want to be listed as a connection to an Internet exchange. If they don't do it, it's up to them. There might be reasons not to be listed, and if they decide not to be listed, it's fine. So if you look at then the right-hand side, what you might detect that there might be more networks really connected to this Internet exchange than listed over there. There might be two reasons. One reason is that the network simply is not registered. Second reason is that the network forgot to also list the connection to this Internet exchange. And the last reason might be that it decided not to be listed for whatever reason. There is not only the graphical user interface, but what nowadays might be even more important is the API. The API supports a read, create, update, and delete operations. And from an API perspective, which is hidden behind the graphical user interface, we have several types. Of course, what I've already talked about, we have the organization, or the basic records, how we call it. These are organizations and the networks, facilities, IXs, and point of contacts. The networks and IXs and facilities, I directly have the next route is the organization and point of contacts. Currently, only networks have point of contacts. That might change and definitely perhaps will change in further releases because it also makes sense for facilities to have point of contacts. Then we have so-called derived types, which is the combination of Internet exchanges and facilities, Internet exchanges on their LAN information, Internet exchanges and prefixes, then networks and facilities, and networks and Internet exchanges. So, for example, what does it mean? It's a combination. The record holds information, the net ID of the network and the facility ID. With this information, you are easily able, for example, if you want to query the database, which network is in which facilities, then you query the facilities and say, I only want the facilities which have the network ID of XYZ. And then you get a list of information about these facilities. The API is very lean. Most of the records are only, let's say, 5 to 10 lines long. You may also drill into it. So you may specify several parameters like depth. If you give the depth parameter, it will recursively try to drill as down as possible into the information. For example, if you call an IX with a depth, it will try to retrieve also the information about all the networks which are connected to it, to all the facility where this IX is in, and so on and so on. Just an example. So if you want to retrieve the whole information for a record, simply query, for example, API net, and then you get information about all the networks. But you may also single out a specific network, and then you specify the ID of the network. So what you see, 20, it's not the AS number. If you look down, the AS number is 63311, but it's the identifier. Each of the record has an identifier. And if you query it via API, and also if you look at the graphical user interface, what you always see is the identifier. As already mentioned, you may limit your query. This because sometimes you are only, for example, you simply want to count how many networks, for example, are in one facility or other information. You want to know with which other networks someone is peering, and so on and so on. So you are able to limit it with a fields operator to say, I'm only interested in ID, org ID, name, and so on and so on. And then the output is restricted to this information. Coming back to PeeringDB itself, as an organization, as said, the database itself, it's around since 15 years, and roughly 5 to 6 years ago, a lot of people found out that this is crucial information which is needed for interconnection, and that there should be an organization behind it. And this led to the creation of the PeeringDB Association, which is a so-called 501c6 volunteer organization based in Seattle in the US, and which is 100% funded by sponsorships. Why did we choose the sponsorship model? An alternative model would have been to charge the end users. End users are almost everyone. So, and even if we would restrict it to those who put in information into PeeringDB, this is thousands, if not 10,000. We were simply unable to do that. The other reason, of course, is we would encourage everyone to put in information. And if we, on the other hand, would bill you for putting in information, perhaps would refrain to do so. That's the reason we went to the sponsorship model, and we have to say we are very happy with the sponsorship model. We have a lot of sponsors, and by having the sponsors, meanwhile, build up and also organizationally healthy organization. And what we try to do is to make a 2 years reserve so that we are sure that PeeringDB is around this year, next year, and also the year after next year. Who is able to become a member of PeeringDB? Almost everyone. You have a record on PeeringDB, that's already one half. The other half, what you have to do is simply subscribe to our government mailing list, and then the organization which you belong to is a member of PeeringDB. As a member of PeeringDB, you might vote, and you might also be voted on. For example, you might run for a seat as a director on PeeringDB. We do membership meetings once a year, and we also vote or elect half of the board once a year. That means we swap out half of the board every year. The board is looking for the strategic directions and looks after the financial matters, but the day-to-day work is done by so-called committees. This, from left to right, The admin committee, in a normal company, you probably would say this is a support department. Whenever someone wants to add a record to PeeringDB, this will generate a ticket to our support department. The support looks into it, especially if someone tries to create a facility. It's hard to detect from the website or automatically detect whether behind this organization there is really a colocation company or an internet exchange. So we still need users to look at it. For networks, it's easier because what we do, we take the information from the RIRs. And if we find this record in the RIR, it's good. And if we also are able to find the request's email address in the RIR record, we even automatically approve this record. The next one is the operations committee. Of course, the whole database, the websites, they have to run somewhere. Meanwhile, they run in the cloud. Therefore, there have to be people who have to look after it, to take care of the day-to-day work, and also for further developing the we call outreach committee. The outreach committee manages marketing and social media. For example, if you have looked at Twitter today for PeeringDB, whenever we have a presentation or we have a new release, there will be something on social media. What outreach also does is to take care for presentation, to look around for events, and also to look around for other organizations which we can work with. What we also did is not only having presentation, but tutorials. We have found out that what we have on our website and what we do in presentation is not enough to really understand PeeringDB. It takes more, and that's the reason we also have, meanwhile, tutorials. The last one was last week at the FPIF conference. And last but not least is the product committee, which takes care of the product development. So we use this GitHub for product development. Whenever you run into a bug or want a feature, simply open an issue in PeeringDB's GitHub, let us know, and we will take care of that. Because so many issues piled up, and because the product development is so important, we hired our first employee, and this is Phyllis Yilmaz, which might be known to the community. And Phyllis is with us from the 1st of April now, and she exactly does what I've talked about. She looks into the GitHub, she tries to shepherd the issues, come to a consensus. She also is responsible for the implementation and rollout, and she maintains the release schedules. So the latest release should have happened. Today is the 28th, I guess, at 4 o'clock in the morning. We have the latest release. We roughly do one release every month. That is not a strict rule, but when we do release, it's always on Wednesday, and we avoid to do it on when there are special events like big networks, NANOC or so, or if there are holidays. This is a quick look on the support statistics. You see a quick increase since 2016. In 2016, we rolled out the new software which is behind PeeringDB, which we internally call PeeringDB 2.0. And the increase in tickets does not mean that there were so many bugs, but as I mentioned before, every creation of a record spawns off ticket in PeeringDB. As you can see from the right-hand side, we do roughly 30 tickets per day. And there's a group of volunteers which look into that. And the lower line, what you see is the resolution time of the tickets, the average resolution time. And we were able so far in 2019 to resolve a ticket in 0.21 days. This is less than 5 hours, which is not that bad, I guess, for a voluntary organization. As mentioned, we have the financial or the money comes from sponsorships. We have different levels. The lowest level starts as low as $200 per month and goes up to 25,000 per year. This is a list of our valued sponsors. And as you can see, we have diamond sponsors, Amazon, Microsoft. And as mentioned, these are organization networks which do heavy peerings and which really benefit that PeeringDB is all around. And not only the big ones benefit. So you as a network, if you want to peer with someone, it's easy for you to build own tools to retrieve information from PeeringDB. And I would also encourage everyone to say to your peer, please have a PeeringDB record, keep it up to date, because then I'm able to retrieve all the information from PeeringDB. So only a few minutes left to mention as PeeringDB is open source meanwhile. We did this last year. The reason is that you also should be able to contribute. And the second reason is that we don't want to hide anything from you. You should be able to look into, to proofread it, to be sure that PeeringDB is safe and is working. I skipped that. Maybe this is also important. I do not know in South Africa how many official languages you have, 10, 20, I do not know. 10, 11. So the most spoken probably is English, but all around the world we have, I do not know, thousands of languages. When we came up with PeeringDB, there was PeeringDB only in English. But luckily, internationalization was already built in to PeeringDB. And what we started last year already, because of the heavy users in Brazil, that we provided PeeringDB in Portuguese. Meanwhile, we have a couple of languages, and I only can encourage everyone, if he feels safe, a little bit safe in translating, and wants to help us to translate PeeringDB to your language. Nowadays, you're already able to choose a different language in PeeringDB. Simply log in, go to your profile, and select the language you want PeeringDB to be in. So this is a list of languages which we are working on, and we decided whenever a language is translated to more than 80%, we will put it into production. So this is a slide on how to contribute. It's quite easy. You only have to have more or less PeeringDB account and let us know which language you want to work on. As soon as you let us know, we will put all the language into our web blade server, our translator PeeringDB.com, and then you log into translator PeeringDB.com with your regular PeeringDB account and start translation. And that's it. The last slide simply has more pointers to PeeringDB. Thank you very much. So, and I guess the only takeaway perhaps from this morning's presentation is if you have a network facility on IX, you should have a PeeringDB record and keep it up to date. So any questions? Yeah, Greg?
I spoke to you last year or the year before about when PeeringDB will be geographically distributed. I still did a trace route now, and it still sits on the other side of the world.
Yeah. So we are still working on that, and I'm always nagging my colleagues from ops. So we did the first step, that we brought it to the cloud. The next step is to containerize the service, and hopefully we will be able, maybe this year already, to then also geographically distribute PeeringDB. But keep on asking me. Thank you. Thanks.